So now that we've had exposure to all of the different quadrants that an angle could be in, I want to talk about how to deal with angles that are outside of the first full rotation of the unit circle. So either 0 degrees to 360 degrees or 0 to 2 pi in terms of radians. What we're going to introduce is the idea of a coterminal angle. A coterminal angle is an angle that has the same initial side and terminal side as another angle. Same initial and terminal sides for an angle in standard position. So as an example, if I were to draw an angle in standard position, we'll make this one a quadrant 2 angle. There are actually lots of different ways that I can rotate from the positive x-axis over to this angle. For example, I could also go in this direction and wind up at that same terminal angle. Also, if I felt like going crazy, what I refer to as the dizzy toddler, we could also rotate around a whole bunch of times. Now, for the initial angle that I created, which was simply a rotation from the positive x-axis over into quadrant 2, that would be considered an angle within one of these two ranges here. The red angle that I created would be considered a negative angle, which is definitely outside of this range, and the purple angle that I created is one that is considerably larger than one full rotation. So in the event that we have, say, a negative angle or something that is rotating more than that, how do we get it to this more natural looking angle right here? So coterminal angles, so we'll say this, two angles are coterminal. We'll give them angle names, we'll call them alpha and beta. Two angles are coterminal if the difference of those two angles happens to be a multiple of a full rotation. So the way that we say a multiple of a full rotation is k times a full rotation, where k is going to refer to an integer. Now, typical ways that we would say something like this is either k times 2 pi, if we're working with radians, or 2k pi, or 360 degrees times k. Now, what we can take out of this is that given an angle, I can find a coterminal angle if I were to add or subtract any multiple of 2 pi or 360 degrees. Now, I keep saying plus, but integers can be positive or negative, so technically you can add or subtract as many full revolutions as you want, depending on working with degrees or whether we're working with radians. So with that in mind, I want to take a look at a couple of examples of angles that are considerably larger or smaller than one full rotation. So first off, we have the sine of 1950 degrees. I went with 1950 because that is my birth year. Anybody believe that? No? Okay, that's fine. So first thing I want to do is a little algebraic aside and just figure out 1950 degrees is working with how many revolutions. So I'm going to convert from degrees into revolutions. Now, I don't happen to know what this is off the top of my head, so I'm going to break out the old graphing calculator and see what we can come up with. So 1950 divided by 360 lets me know, wow, let's try that again. 1950 divided by 360, this lets me know that it's between 5 and 6 full revolutions. I'm interested in an angle that's between 0 and 1 full revolution. So it's 5.4-ish. So what I'm going to do is take my 1950 degrees, and I am going to subtract 5 full revolutions. The way that I do so is say 5 times a full revolution in terms of degrees. This one's going to be a little bit easier to calculate than the last one. That'll be 1950 degrees minus, that's 1800 degrees. That gives me 150 degrees. This lets me know that 1950 degrees is coterminal to 150 degrees. So the sine of 1950 degrees will be the same as the sine of 150 degrees. Now, we still need to figure out what the sine of 150 degrees is. I'll point out that 150 degrees is between 90 degrees and 180 degrees. So we'll sketch that over here, a little closer to 180 than it is to 90. And for our reference angle is going to be this guy right here. Now that is the angle that is between 180 degrees and 150 degrees. So we'll perform that subtraction and get that our reference angle is a 30-degree angle. Now given that it's a 30-degree angle, we are now dealing with the 30, 60, 90 right triangle, and I would label the sides appropriately. Now the sides would be 1, 2, and the square root of 3, but because we're in quadrant 2, the horizontal side, square root of 3, would have to be negative. Good news is, I'm not really interested in that part because we're looking for the sine of this angle that would be opposite over hypotenuse. This would be equal to 1/2. Additionally, if we have an angle that is negative, we can do something similar to this. So we have the cosine of negative 9 pi over 4. Now, negative 9 pi over 4, first thing I'd like to do to this is add a full rotation to it. We'll add 2 pi to it. Getting a common denominator, this would be negative 9 pi over 4 plus 8 pi over 4, which is equal to negative pi over 4. Now that's not technically within the first full revolution of the unit circle, but I think that it is going to be enough for us to deal with. If we were to convert this over to degrees, just to feel a little more comfortable, that would be a negative 45-degree angle. It actually makes the reference angle considerably easier to figure out. So negative 9 pi over 4 would have been this angle, like so. By adding one full revolution to it, we've turned it into this angle right here. Now the good news is, we've basically already calculated what the reference angle is for this. This would be a 45-degree reference angle. Now, given that this is 45 degrees and that this is a right triangle, we are now dealing with the 45, 45, 90 right triangle. I can label the sides appropriately. 1, 1, and the square root of 2. We're in quadrant 4, which means that the vertical side is going to have to be negative. That way we can consider this to be the ordered pair 1, negative 1. We're looking for the cosine of this angle. The cosine of this angle, cosine of negative 9 pi over 4, is going to be the adjacent side over the hypotenuse. So that would be 1 over the square root of 2. Or if you feel like rationalizing the denominator, that'll be the square root of 2 divided by 2.